Let us sketch a function f satisfying the following conditions. For this problem, we can come up with several solutions. No? So we're just going to draw one possible solution for the function f. The function f has the domain -2 to +2, close interval from -2 to +2. So we can start by limiting the domain of the function from -2 to +2. So meaning to say, there will be no graph. No? There will be no graph left of -2 and right of +2. So let us disregard these regions. Alright. So the graph will appear only from -2 to +2. Next, the function values f of -2, f of -1, f of 1, and f of 2 are all 0. So these are the points -2, 0, -1, 0, 1, 0, and 2, 0. So these 4 points are part of the graph of f. Next, f has an infinite discontinuity at -2. Since left of -2 is not included in the domain, then the infinite discontinuity appears right of -2. Either it is positive infinity or negative infinity. But it cannot be both. No? So it's either positive infinity or negative infinity. So let us just say that it is positive infinity. Alright. There is a jump discontinuity at -1. So if this is -1, and since we have the point -1, 0, then we have to consider another point. But that point is excluded. No? So we can say that is the point -1, 2. But that is excluded. No? And we can just connect this so that we will come up with an infinite discontinuity at -2. Alright? What else? There is a jump discontinuity at 1. Since that point 1, 0 is in the graph, and if there is a jump discontinuity here, then we must consider another point here, but it is excluded. Say for example that is 1, 0. Okay, and there is an infinite discontinuity at 2. If there is an infinite discontinuity at 2, then it should be left of 2, either positive infinity or negative infinity. So any of these two. Let us say negative infinity. So negative infinity. Alright. Next, f is continuous from the right at 1. F is continuous, by the way. No? There is infinite discontinuity at 2, and then we have this point 1, 0, then we can connect. We can connect this there. And it will still satisfy the condition. Alright, there is a jump discontinuity at 1 and an infinite discontinuity at 2. And finally, f is continuous from the right at -1 and continuous from the left at 1. Since these are 2 points, -1, 0 and 1, 0, are points in the function and continuous from the right at -1 and continuous from the left at 1. That means that these 2 points are included in the graph, connecting -1, 0 and 0, 1. So we can say that this is something like this. There. So let us check. The domain of f is from -2 to 2. F of -2, f of -1, f of 1, f of 2 are all equal to 0. Then there is infinite discontinuity of -2, jump discontinuity of -1, jump discontinuity at 1, and infinite discontinuity at 2. F is continuous from the right at -1 and continuous from the left at +1. So that's one possible solution to our problem.